So my name is Piotr. I'm the president of the Warwick Training Society. This week and next week, which is week 3, will be presented by us. Next week will be presented by Alfie. So just as a recap, last week we covered variables and operators. So variables are sort of named references to values in memory, and then various operators, especially mathematical ones, like plus, minus, things like that. Data types and casting, so different types of values. We had ints, floats, strings, and casting, so ways of sort of conversing between them, and then different sort of intricacies that you have when you convert between one another. Then we went on to basic debugging and exceptions, sort of how to understand what went wrong in your program and different types of exceptions and errors that you can get. Then we went on to print and input functions, so how to sort of output some text to the console and how to take input from the user as well. This week we're going to cover string formatting, essentially sort of applying different operations to strings, and more specifically we're going to go through f-strings, which is a standard way of formatting strings in Python. Then we're going to move on to comparison and logical operators, conditional statements, which sort of control the flow of the program based on certain conditions. And then we're going to go into creating our own functions. So we've already encountered the print and input functions, but we're actually going to go into defining our own functions at the end of this lesson as well. So moving on to string formatting. So last week we experimented a bit with string concatenation. We had sort of different variables being added to strings, and we just did that using the sort of plus operator. But a much easier way of doing this is through f-strings. So f-strings are the sort of standard way of formatting strings in Python. The way they work is you sort of take a string, you prepend the character f to it, as we see over here in this print statement, and then you use these curly braces to add any kind of expression into the string, which is then evaluated, and its value is sort of inserted within that string itself. So here we have, as an example, a society variable whose value is the string X-Soc. Then we print out the string I am joining, and then the value of the variable society. So that's sort of one way of doing it, and then we can also add multiple different expressions into an f-string. So lower down we have society 2 and society 3 working and UWCS, and we print I should also join society 2 and society 3. But I really want to stress that you don't just put variables in these, you can put any type of expression that then gets sort of evaluated, and the value is converted into a string and inserted into the final string. So here we have a calculation, I am, and then we have a mathematical calculation, years old. And what that will do is essentially it's going to evaluate that expression within the f string, get its value, and then add that to the final string. So if we get the output of this, we see that all the sort of relevant values that we had, or all the relevant expressions that we had in the f strings were evaluated, and their values were added to the final string. So we have I'm joining X-Soc, I should also join Warwick AI and UWCS, and I am 19 years old. So that's all there really is to f strings. We just wanted to introduce it because we're going to be using it later down the course. It doesn't really add to Python's expressionless in any way. It's just a nice sort of shorthand notation that allows you to concisely add variables and values and expressions into strings. But of course, you can do the equivalent operation just using the sort of plus operator that we had last week. So for example, down here, if I edit this, I can just have one string here, and then I can plus convert the result of this expression to a string, and another string at the end. And this is going to result in the same output as before. So your f-strings, as I said, they don't add any expressiveness to the language or additional expressiveness, they just sort of add another notation of what we did last week, and we're going to be using that from now on. Okay, so now moving on to logical and comparison operators. So last week we covered sort of the main 3 data types, which aims for those in strings, but now we have another one, which is Boolean, also extremely common in most programs. So Boolean is essentially a data type that represents, or rather has one of 2 values, true or false. And they're very, very commonly used in programming to sort of decide the flow of a program, which we're going to see with control statements later on. But essentially what you can do is you can have a statement saying, if this value is true, then do this, otherwise do this. We're just going to see in a second. But yeah, so if we run this, we'll see we have this expression here, 5 is greater than 2. This will evaluate to true because the value of 5 is greater than the value of 2. And then here we have 2 is greater than 5, and this will evaluate to false because obviously 2 is smaller than 5. So if I run this, you see the output as true and false. And these are the Boolean values themselves. So this is not a Boolean value, this is just an expression which, when evaluated, results in a Boolean value. And of course, we can assign the Boolean values to variables as well. So here we have the variable a, we assign it to true, and we can print out a, and we get true. Note this is different from something like this. So this is a string which contains text true, but it is not a Boolean. Whereas this is a Boolean. So note the lack of quotation marks. Now moving on to comparison operators. So I think last week you might have seen sort of less than, greater than, and here we have a list of sort of the main comparison operators that we have, typically using numbers. So we have equal to, which is a double equals. Note the difference between a single equals and a double equals. So a single equals is just the assignment operator. So when you're assigning variables, like up above here, you use a single equals. When you check for equality, you use double equals. We have not equal to, which is exclamation mark equals, greater than, less than, so on and so forth. And when you use the comparison operators and expressions, their results will evaluate to either true or false, because something can either be equal to something or not something, or greater than something or not greater than something. So here we have a couple of examples. Again, 3 equals 2, this is false. 3 is not equal to 2. True equals true, that's true. The value of true is equal to true. And then we compare two strings. X-Soc equals UWCS, this is false. These are two different strings, contain different characters. If I run that, you will see the output below. And yeah, as I said, just another note, don't forget that the second equal sign is testing equality, whereas just a single one is doing assignment. And we have sort of other examples with not equals to. Here we have sort of 3 other comparison operators used on numbers. But one thing to point out, even though typically you're going to use numbers, you can use them on sort of any data which has a natural ordering. So for example, you can use it on strings, and the ordering there is the alphabetical ordering. So for example, down here, if I add in another statement where I print A is less than B, intuitively this might not make much sense, but actually because there is a sort of alphabetical ordering between characters, this is valid Python code, and if we run it, this will evaluate to true, because A comes before B in the alphabet. Okay, now moving on to logical operators. So these are sort of used to combine Boolean expressions. So we have 3 main ones. We have and, or, and not. And is used to check if both sides of the expression are equal to true. So it will evaluate to true if and only if both expression 1 and expression 2 are true. Then we have or, which will evaluate to true if and only if at least one of the expressions is true. And finally we have not, which is sort of like an inversion. So if you have not true, that will evaluate to false. And if you have not false, that will evaluate to true. And these are sort of used, as I said, to combine different Boolean expressions. So here we have print 3 equals 3 and 2 equals 3. So 3 equals 3 will evaluate to true, but 2 equals 3 will evaluate to false. So the overall result of this expression will be false, because even though the left side is true, the right side is false. And for and to evaluate to true, we need both of the sides to equal to true. Here we assign some variables, and we do some sort of more complex Boolean logic. Here we use sort of parentheses to make this a bit more readable, but actually because we're just using AND operators here, it doesn't change the output of the Boolean expression. But you can use parentheses to sort of set precedence. So one thing we go into here is the precedence of these operators, which is not followed by AND, followed by OR. So if you have an expression with multiple of these operators, for example, like not true and false, then these will be evaluated in the order shown below. So first you evaluate first you evaluate not, then you evaluate and then you evaluate or. And if you want to sort of change that precedence, you can use parentheses, because parentheses have the highest precedence. They will be sort of evaluated first. So anything inside of parentheses, such as this here, will be evaluated before anything outside of parentheses, just like you have in sort of maths as well. So if we run this, we can sort of see all the outputs of this. So as I said, the top one will evaluate false because the right side is false, and the rest of these are true. You can sort of go through them. So A equals to B, that's true because they both have the value 2. The string A is equal to string A, they are equivalent, and true is not equal to false, that will evaluate to true because true and false are not equal. So the entire statement, when sort of combined with the AND operator, evaluates to true because all of the sort of sub-statements or sub-expressions evaluate to true. And below we have sort of the equivalent one without parentheses. Here we have the modulo operator, which was covered last week. This will sort of perform division and get the remainder of the division. So 5 modulo 2 equals 0, that's false, because there's a remainder of 1. Or 8 minus 5 equals 3, this will evaluate to true. And because we use the OR operator, we need only one of the sides to be true for the entire expression to be true. So overall we get true. But also with the OR operator, you can have both of them being true. So at least one needs to be true, but both can also be true. And then it will evaluate to true. We have some sort of further examples down here using direct Boolean values. But that's really it for comparison and logical operators. You'll see them a lot more when we combine them with conditional statements. That's where they'll sort of get their use because you'll be using them to control program flow. So now moving on to conditional statements. The main ones we sort of have are if, else, if, and else, and then match case. So sort of first covering if, else. These are used to check Boolean expressions, and if an expression is true, they will execute some piece of code, and if not, they will sort of continue program execution or evaluate any further elif or else statements that might be part of the if statement. So here you can see the syntax. We have if expression 1, which would be a Boolean expression, then execute this piece of code. Now note the use of white space here. Anything that you want to be a part of the if code block needs to be indented by a tab, otherwise it will just be counted as sort of code that's outside of the if statement. And then we have elif and else as well. So elif will only be evaluated if the if fails. So if the expression within the if statement evaluates to false, then we move on and we check the elif. We check if expression 2 evaluates to true. If it does, then we execute the piece of code associated with the elif statement. And if it doesn't, then we move on. And then else is something you sort of fall back on. So the else will execute only if all the expressions above, or sort of all the if and else statements above evaluated to false. So if you want some piece of code to execute if all the other expressions evaluate to false, then you put it in the else statement, or in the else sort of code block. So here we're saying if expression 1 is true, then execute block of code 1. If expression 1 is false, but expression 2 is true, then execute block of code 2. And if both expressions are false, then execute block of code 3. So now moving into some actual Python code. Here we have a variable called age with the value 25. We check if the age is less than 18, and if so, we print you're underage. And then else, we print just above. So the way this will sort of evaluate is, again, it will check the value of age, check if it's less than 18. We see that it's not because it's 25, so the value is false. So then we go to the else statement and execute the block of code associated with that. So if we run this, we'll see that we get something goes to the top as the output. And then if you want to have more than 2 conditions, you can add them with elif. So over here we have a longer example. We check if x is equal to 0. And if it's not, we check if x is equal to 4. If it's not, we check if it's greater than 0. And otherwise, if all those conditions evaluate to false, simply print x is strictly negative, which we able to sort of determine by having the previous if statements there. So if we run this, we'll see x is equal to 4 being printed, which is sort of code associated with the first elif there. And note the difference between having elifs and just a bunch of ifs. So elifs are a part of sort of the previous if statement. They're associated with the previous if statement. And they will only be evaluated if the if statement and any elif statements above have evaluated to false. Otherwise, they'll just be skipped. So in this example, if x is equal to 0, if that evaluates to true, then all these other elif statements will be skipped. So we can see that if we change this value to 0, and we run this, we just get x is equal to 0 as the output, even though x is also, let's do elif is greater than equal to 0 here. And we change the message here. If we run this, we still get x is 0, and the second message is not printed out because the if statement evaluated to true, and all the elif statements below are just sort of skipped, because saying else, so only evaluate it if the if statement and the above elif statements evaluate as false. Whereas, if we have something like this, where we have multiple if statements, but not elifs, they'll all be evaluated regardless of the output of the previous if statements. So even if they're sort of all independent from each other, and even if a previous if statement evaluates true, the next if statement will still be evaluated. So here, if we run this code, we'll get x is equal to 4 and x is strictly positive. And here, sort of, if we change this to an elif, you see that the second part will not get executed because the first part, the if statement evaluates as true, so all the elif statements are skipped. So this is something that a lot of beginners sort of trip up on. Make sure you know the difference between having an if for a bunch of elif sort of following that, and just a bunch of if statements next to each other. And yeah, I just have a note here. As I said before, white space counts as code in Python. So by white space, we mean spaces, tabs, and new lines. And all of these sort of count as code as well. So in some languages like C or Java, white space is just sort of removed during compilation, and it doesn't change the sort of output of the code in any way. But in Python, it does actually matter if we tab something or if we put a space somewhere. So here, for example, we have if x is equal to 4, and we have print x is equal to 4. But because this print is not tabbed over, it's not counted as the body of this if statement, and we actually get an error, an indentation error, because the print statement is not indented. So to make it part of this if statement, we just have to tab it over, and then we get the correct output, x is equal to 4. And you can also nest if statements. By nest, I mean you can put sort of if statements within the bodies of other if statements in this sort of format. So we can have if condition A, and we have something for that executes if condition A is true. And then within that body of that if statement, we can have another if statement saying if condition B, and that will only execute if condition A and condition B are true, because this is within condition with the body of the first if statement. So we already know that if this if statement is being evaluated, then the one that is nested within must have evaluated true. So we have a sort of more lengthy example here. We have three variables: age, has graduated, and has license. First, we check if age is greater than or equal to 18, and within that we have the sort of body of that if statement and some nested if statements. So within that we also check if has graduated is equal to true, and if has license is equal to true. But these if statements will only be evaluated if the sort of outer if statement is evaluated to true, because they're nested within that if statement's sort of code block. So if we run this, we see that we get this initial message, you're 18 or older, well, it's adopted, because age is 19, and then we move on. We check if has graduated is equal to true. It's false, so we don't execute this print statement, and we check if has license is equal to true. We see that it is, we print no crash, and then we don't execute the else because this has evaluated to true, and we also don't execute this else because the initial if has evaluated to true. Yeah, so here's just a sort of explanation if you don't follow along. Now moving on to matched case statements. So when you have a case where you want to check a single variable for an expression for equality, instead of just chaining multiple if and else statements together, you can have a matched case statement where you pass in the expression for the variable to match, and then you have a bunch of cases which will compare that sort of variable expression or the value of that expression that you pass in to match against each of these cases. So here we have a variable called happy, which is true, and we matched on happy. We have two cases, true and false. So if we match true, meaning that the value of happy is true, then we print out happy emoji. And then if we match it with false, so if the value of happy is false, we print out sad emoji. And another example, so we were matching on a Boolean value here, but we can also match on sort of any piece of data that you can compare for equality, check for equality. So we can have this match case statement, which checks the month number, and depending on the number of the month, we print out the name of that month. So we check if it's 1, then we print out January, if it's 2, February, so on and so forth. And then sort of analogous to the else statement that we saw if and else, we have this underscore case, and this basically matches anything that hasn't matched the previous cases. So if we have a number that's not between 1 and 12, then it will match this sort of final case with the underscore, and we print invalid month number. And here we just have a little comment saying that this is equivalent as the sort of if code, or the sort of if clause with a bunch of else statements checking for equality. So again, it doesn't really make Python any more expressive, but it makes it more concise. And yeah, if you just have this case where you're checking for equality a lot, it's much more cleaner, it's sort of more concise to use a match case statement, as opposed to just having a bunch of if else chained together. So if we run this code, we get happy face and the month of May. And here, if we change the month number to something outside of the range, so if we do 14, we'll get invalid month number, because this case has not matched any of these cases, because the number is not within that range. So it matches this sort of else case, and we print out invalid month number. And then with these cases, you can have multiple values that you check for the equality of within a single case. And the way you do that is just with this sort of vertical line symbol. So here we have response codes, which are sort of HTTP response codes, but you don't need to know that. Just know that we're checking for a bunch of different response codes within each of these cases. So initially, we're checking for these response codes that are in the sort of 100 range, 200 and 300 and so forth, but we're checking for multiple values within each case, whereas previously we were just checking a single value. So here we're checking just for like 10, and here just for 11. Whereas down here, we're checking for 100, 101, 102, and so on and so forth, all within a single case. And all of these values will match to this case, and then we'll have this being printed. The value is 403, so it will match this case over here, where we check for sort of 400 response codes. If we run this, we see the message that we get is recognized by our response, because we've matched this case statement over here. So that's all for traditional statements. Now we're going to be moving on to functions. So as I said at the beginning, we already saw two functions at least. We saw the print function and the input function. So functions in programming are kind of analogous to functions in mathematics. So you can have functions that sort of take an argument and they'll perform some transformations and then give you some sort of output. The programming is a bit different because some functions are sort of going to take arguments, and you might have functions which also don't return anything, which we'll see in a second. So the way you define a function within Python is using the def keyword. So here we define a function called greet. So we do def, greet, open close parentheses. We'll see the use of those in a second. Use a colon, and then we have the body of that function. Anything that you want to be a part of that function has to be indented over, just like with the if statement. So anything that's indented over after the function definition will count as being a part of that function body. And then to actually call that function, to invoke that function, we just write name with the parentheses, and that will call it, meaning we'll execute the function of that body. So we see when we call greet, we get hello human being printed out, and we can just sort of call it again, and we'll get the same output being printed out twice. So their main purpose is to sort of reduce code duplication. When you have code that you want to reuse multiple times, instead of just copying and pasting it, you can put it into a function, and you just call that function instead. So as I said, with mathematics, you have sort of arguments that you can pass as functions, and it's the same in programming, parameters. So when you define a function, you can also define parameters, which are sort of variables that that are associated with that function definition. And the way you do that is in these parentheses. Now, there's a distinction between arguments and parameters. So arguments are the actual values you pass in to the function. So for example here, the string James is an argument that you pass in that function, whereas the parameter is the actual sort of variable that you define along with that function. So here, name is a parameter. It's a variable associated with that function, or at least one of them. You have multiple parameters, just arbitrary number of parameters with a function definition. So yeah, oftentimes you want to sort of change the behavior of the function depending on what you pass into it. So for example, you can have this greet function where you greet someone based on a name. So you can just pass into a name, pass in the name to the greet function, and then it will print hello along with that name. So here we're using F strings again. So if you output that, you'll see hello James, hello Tom. So the string is being passed into this function, and then the value of it is sort of substituted into this string itself here, where you have hello name, and then that's output into the console. So functions can also return data. So if you pass something into a function, you can have it sort of perform some transformation and then return the output. Or you can just return something without passing any parameters as well. So you could have like a constant function which returns maybe the value of pi or something like that. So over here we define a function called double, which takes a single parameter called none. And when you pass in that argument, it will return you none double. So over here we call it twice, one to a value of 5, 42, so we should get 10 and 84 as the output. So essentially what we're doing, and this is kind of like a nested function call. So first we call the function double with the argument 5, and then whatever the result of that function is, we pass into the print function, which then outputs it into the console, into the terminal rather. So now, sort of just to stress that point of reusing code, we can rewrite the previous match case statement that we had for determining the name of a month based on the value, and put that into a function itself, so we can sort of reuse it rather than having to rewrite it every single time. So we have this new function called month name, which takes a single parameter called month num. Then we match based on that parameter, check for its value, and depending on its value, we return a different value, or a different month name. So here we call it 1 and 12, so that should return January and then December, respectively. Yeah, as you see the output, that's what it does. Essentially just sort of calls the code within that function while also passing any arguments that you call the function with. And functions can, of course, call other functions within that body as well. So we have the double function where we double the argument that's passed into the function, and we can define a quadruple function, and instead of that just multiplying by 4, we can just return double called twice on the argument that's passed into quadruple. So see here we pass in 10 as the argument, we call quadruple of 10. When we run that, we see 40. Essentially what it does is we call this function with num here, which is set to 10. Then we call double on that value, which will double it, we get 20. And then the result of that is passed into double again, so 20 doubled, and we get 40. So you can sort of combine different functions together from other functions. Another point of functions is to make your program a bit more modular. So if you want to write clean code, you should have ideally each function being responsible for one single thing. So let's say you want to write a program to perform some data analysis, but you also need to sort of read values from the file. You could do it by just having a single function which reads in values and performs data analysis. But ideally, what you want to do to have it have your code be a bit more modular and reusable is have one function for reading data from the file and another function which will sort of take the data that's already been read and perform the data analysis on that. And then later on, let's say you have to have another function, maybe you want to add the functionality of I don't know, copying a file over or something like that, then you can reuse that function of reading a file rather than having to copy the code again. So yeah, just to stress on that point, every function should be responsible for one thing, and that thing only. So that's everything for this week.